Okay. Not only do we want to find z-scores, sometimes we're going to be given a z-score, and we're going to use that one to go backwards and figure out a value. So sometimes, like I said, so sometimes you're given a z-score and need to find the value that has that particular z-score. So to do this, we're going to multiply the standard deviation of z and then add the quantity of the mean. Or what we're doing is this. We know z is this x minus mu divided by sigma. And we want to solve for x. So what we end up doing is we're going to multiply both sides by the sigma. So it cancels out here. So we have z times sigma, so z-score times standard deviation equals x minus mu. Now with the x by itself, so I'm going to add the mean. So I'm going to have z sigma plus mu going to equal x. Or another way of saying it, x is going to be your mean plus your z-score times your standard deviation. So in a population with a mean mu and a standard deviation of sigma, the value of x is given with a given z-score is going to be mean plus z-score times standard deviation. So data from the National Health and Exam Survey estimates that the total cholesterol level in milligrams per deciliter of blood in adult population be 200, the mean to be 200. And we have a standard deviation of 44 milligrams per deciliter. We want to know, what is the cholesterol level of a person who has a z-score of 1.5? So x is going to be mu plus z times sigma. So it's just going to be 200 plus 1.5 times 44. So that would be 66. So we should end up with 266. If somebody's z-score was 1.5, then we are going to know, based on the information we have, like if we were just told their z-score is 1.5, we can go back and estimate. Well, that means that their cholesterol level was, 266. So we use z-scores actually as a benchmark to certain things. So the intelligence quota scores, so there's several different ones. So I only picked one of the scalings for this, but the intelligence quota scores or IQ scores have a mean of 100 and a standard deviation of 15. So that's supposed to be across the board everywhere. This next part, like I said, it depends on the scale you look at, but a score between negative 0.66 and 0.6 is considered average intelligence. So if you're between those z-scores, that's average intelligence. And sometimes, like if you've had your child get tested for something, like a gifted and talented, or they're testing them for, evaluating from other reasons, they may have done their IQ. And sometimes they'll talk about their IQ in terms of a z-score. That happened with my son. They were fortunate that I knew what they were talking about. But we want to know is, what is the range of IQ scores for an average intelligence? So take a moment and see if you can find that. Okay. So we know if we're trying to figure out what the score is, that's my x. So that is going to be my mean plus my z-score times my standard deviation. So I know what my mean and I know what my standard deviation are. And these are the two z-scores that I have. So if z-score is negative 0.66, the IQ score that goes with that is just going to be 100 plus negative 0.66 times 15. And I forgot what the score was supposed to be, so bear with me a second here. 100 minus 0.66 times 15. Okay. So this is going to be a minus 9.9. So the score we get is a 90.1. So it's actually like, I think supposed to be 90, but there's a little bit of rounding in here. So with normal intelligence, it runs from about 90. And then the other part of it was a z-score of 0.6. So that is x equals 100 plus 0.6 times 15. And this is going to give me a not as 109, so that's about 109. So depending on where you're looking at scores, so sometimes they actually use like full standard deviations. So 2 standard deviations above the mean is actually considered not gifted, but bright. And if you look 2 standard deviations below the mean, so in this case, this is a below the mean. Because it's a negative score, so we're going to get something that's less than 100. This is above the mean when I'm talking about above the mean. Because this z-score is positive, that means we're going to get a score that's larger than the mean. So we actually use standard deviations as kind of benchmarks for certain things. And like I said, 2 standard deviations above the mean is considered bright. 2 below it is when we start calculating something as an intellectual disability. So we do use these z-scores as sort of like benchmarks of where we start saying something is like a disability, or where something is, we're considering them bright or genius level or something like that. And like I said, these scores kind of vary depending on what kind of scale you use, because there's different scales in the areas of what's considered normal, what's considered below normal, what's considered above normal. All of that is kind of varies a little bit.